Hey everyone, welcome back. I'm super excited to have you here for this explainer, which is proudly made by Forge College. Now, if you've been following along in our From EVM to SVM track, specifically the module on understanding Solana accounts, you know we're right in the thick of it. Today, we're focusing squarely on initializing and configuring accounts. Basically, we're going to take all that abstract theory we've been chewing on and turn it into actual deployable engineering. So let's jump right in.
Okay, so in the previous lesson, we went pretty deep into rent, lamports, and the whole account lifecycle. We talked about the theory, the rent thresholds, and the economics of keeping your data alive on the network. But, theory is really only great until you have to pick up a hammer and actually build the thing. We know how rent works on paper, right? But how do we actually build the account? How do we draft those blueprints and pour the concrete? Well, that is exactly what we're going to solve today.
Here's our blueprint for today's build. First up, account creation. Second, we'll look at the multi-tenant file system. Third, we'll get into scripting your account blueprint. Fourth, verifying the on-chain build. And finally, we'll wrap up with a recap and next steps.
All right, let's kick things off with Section 1. Welcome to account creation. We're moving from theory to concrete initialization.
Moving right along to Section 2, the multi-tenant file system. Think of this as a familiar mental model for alien landscapes.
Now, if you're coming over from Ethereum, Solana's account model can honestly feel pretty alien. But a Solana account isn't magic. If we map it back to basic computer science, it's actually a lot like a file in a shared, multi-tenant file system. The owner, that's your program mutator, literally the only entity allowed to write or change the file's contents. Space is your reserved disk size, and lamports, think of those as your prepaid lease. And trust me, you definitely don't want an evicted tenant just because you skipped out on the prepaid lease. Nor do you want to try fitting a grand piano into a tiny studio apartment by under-allocating your space. If your data structure is huge, you've got to reserve the right amount of bytes or your transaction is just going to fail.
So let's check out our bill of materials here. These 4 parameters are absolutely non-negotiable when creating an account. First, the owner program. This is the public key of the program that's going to control the account. Second is space in bytes, literally how much room your data layout needs. Third is lamports for funding, which is the exact amount of native token required to make this specific space rent-exempt. And fourth, the executable flag. This just tells the network whether the account is a program itself, which is normally set to false for standard data accounts. You really got to get all 4 of these right.
Which brings us to Section 3, scripting your account blueprint. Here, we're assembling the transaction via TypeScript.
If you're putting together the assembly manual for this process, you're looking at 4 exact steps. Step 1, load your payer key pair. Someone has to foot the bill for the network fee and that initial rent, right? Step 2, generate the new account key pair that you're literally bringing into existence. Step 3, and pay attention, because this is crucial. Calculate the rent using the getMinimumBalanceForRentExemption method based on your chosen space. And step 4, construct and send the createAccount transaction. So again, the big takeaway here is step 3. Calculating rent programmatically rather than just hard-coding some magic number is hands down the safest way to guarantee you never underfund your lease, no matter how the cluster variables might shift around.
Okay, Section 4, verifying the on-chain build. Time to run some quality assurance diagnostics.
Let's see how all of this builds into our success metrics. Look at the stark contrast we have here. On the left side, we've got a perfectly initialized SVM account. It's properly funded, rent-exempt, perfectly safe, and it readily accepts rights from its owner program. Awesome. But on the right, we see a super common pitfall, the underfunded or missized account. Maybe you picked the wrong owner, or maybe you undersized the space. What happens then? Well, it becomes unexpectedly closable. Your program logic totally breaks because the serialization fails, and your data basically gets evicted. We definitely want to be on the left side, not the right.
So, how do we actually make sure we land on that left side? Here is your QA checklist. Whenever you query your new account via the CLI or your script, you need to check these exact metrics. Are your lamports greater than or equal to the rent-exempt amount? Does the owner perfectly match your expected program's public key? Does the data length equal the exact space you requested? And finally, is that executable flag set to false? If you can check off all 4 of those boxes, boom, your build officially passes QA.
Finally, Section 5, recap and next steps. Let's solidify this tightly coupled trio.
Listen, if you take absolutely nothing else away from this explainer, I really want you to remember these 2 practical engineering principles. Number 1, size conservatively but accurately. Overallocating wastes your lamports, but underallocating completely breaks your program logic. You need precision. And number 2, prefer deterministic initialization patterns. Always compute your space from serialized struct definitions and calculate that rent dynamically. These principles are vital, honestly, because they set the stage for safely handling much more advanced topics later, like program-derived addresses and associated token accounts. Having predictable sizing just makes everything downstream so much safer.
And I absolutely love this quote right here. It just hits the nail on the head. Treat owner, space, and lamports as a tightly coupled trio. Changing one usually requires revisiting the others. Think of it like the gears in a Swiss watch. If you increase the data layout, you have to go back and recalculate the rent exemption. If you assign the wrong owner, your program literally can't write to the space you just paid for. You can't just tweak one gear without adjusting the others. The whole shebang has to work together perfectly.
And that brings us to a rather provocative final question. How do these core account concepts ultimately contrast with Ethereum's model? Now that you know exactly how to initialize space, designate an owner, and fund rent on Solana, you might be realizing just how radically different this is from deploying a smart contract on the EVM. But hey, that massive contrast is exactly what we're going to unpack in our next lesson. So, thank you so much for joining me today. As a quick reminder, this explainer was proudly made by Forge College. If you want to dive deeper into this subject, get your hands on some actual code, and continue your Web3 journey, definitely head over to forge.college. I highly recommend checking out the resources there. Until next time, keep building, keep verifying, and I will see you in the next one.